Okay, hey guys, in this video we will be starting with very basics of mission planner, the drones, drone hardwares and many other basic stuffs, and then slowly we will be moving to programming of the drones using DroneKit, PyMavLink, MavSDK. So yeah, let's start with the very basics of mission planner. Let's start our introduction with ground stations. Particularly we will be focusing on mission planner even though we are having an options for Q ground control, QGC. But we will be sticking with mission planner. Why that difference or why I'm choosing with the mission planner is because I'm more comfortable with mission planner, so we will be sticking with mission planner. Yeah, in some videos we'll cover QGC also, Q ground control. This is also really good and it has some good different features. But yeah, like as I'm experienced with mission planner, so in majority of the stuffs we'll be using the mission planner. So basically what ground station is, you're seeing some photos like this, and even if you see there's some GUI over here, it's actually a mission planner. Don't go with the photos, but yeah, something which is on the ground and we are able to control the drones. Something which is on the ground and we are able to control the drones or any UAV or anything which is unmanned. So basically that's ground station. Mission Planner is a software, a ground station software, which provides a lot of functionalities for the same. Again, as we already discussed, what is ground station control or ground control stations? And it's a system, it can be a system, or it can just be a software in your computers that enables operators to control and monitor UAVs. And yeah, as mentioned, it also provides the real-time monitoring of the vehicle's telemetry data. The words like telemetry, position, battery status, some might be familiar and some might be very new. Something like telemetry might be new. Don't worry, we will cover that in a few minutes. What's the exact telemetry and what are the telemetry data? As of now, you can just consider telemetry data. It might be a position, it might be your battery status, or it might like to check where your drone is, whether it is armed or not, in which flight mode it is. Basically regarding this, the telemetry data would be providing. And yeah, as of now you can just consider telemetry data in the sense some basic position, whether it is armed, how much speed it is moving, what's its pitch angle, roll angle, some other stuff. This QGC allows us to operate and take manual control of the vehicle if needed, and we can program it. Program in the sense not the Python program or some scripting programs. This is a different kind of mission planning, we can say. So we'll be able to do that, and we can adjust the speed and heading. We can do a lot of stuff using the just mission planner also. We will see that practically in just few minutes. Okay, as already discussed, why to use it. So first thing is, it offers real-time monitorings. As mentioned, it offers real-time monitoring, and it provides vehicle status and surrounding status. Though there are a lot of things mentioned here, we will discuss that also. And it includes a lot of tools for mission planning. Mission planning in the sense we predefine everything, and the drone takes off and it executes step by step. It's a kind of static programming. You pre-program everything and you just press one button, it launches, it performs everything and come back. Basically we need to define the waypoints and we need to set the flight path, and it will automatically execute everything. But don't go by this aeroplane or the fixed wing. We are having a liberty to use the quadcopters, hexacopters, or the fixed wings or the auto rovers. The rover in the sense, some you can consider as of now as a RC car, and it facilitates, like, there are a lot of efficient algorithms which are inbuilt. You can consider some control system algorithms, and we are having the mission control systems, payload controls, and we are also having the communication systems. Communication systems, you can consider that as something related to telemetry and getting the RSSI value. Like you can see wireless telemetry connections, that's in percentage. And payload, you can control some gimbals, or you can control some parachutes, or you can control some servos by like manually. Mission controls, like you can control all the mission related, as it can do a lot of stuff, but there are certain things which it can't do. And to address, very important, you'll not be able to program that static program. That's not actually a kind of programming, that's very different. But the actual programming we do using the Python, C++, or JavaScript, or these kind of programming. So it's very difficult, or like you can just say it's not possible with our normal mission planners. So programming capability we can't do. So for programming we need to use DroneKit, MavSDK, PyMavLink, or Mavros. These are not ground stations. These are the libraries or tools with programming so that we can use that. Yeah, and naturally our ground station, even though it's having certain capabilities, still it will not be able to take autonomous decisions or instantaneous decisions, especially in the dynamic challenging environments. So there is a few things which our ground station can't do, as autonomous decisions or instantaneous decisions. Even it can perform because there are few algorithms, but still we will consider that it don't have, because whatever the things we are having, that's not for the basic users. These are pretty advanced. Okay, so ground station, as of now till we were discussing only regarding the software, but there are few hardwares also. So in hardware, the first thing would be telemetry. These are the telemetry modules which we were talking just a few minutes back. Even if you see here, there's a thing written here. It's a ground module and this is a air module. So this would be attached with our drones or rovers or any UAVs, and this should be attached with our computers. Basically, the thing where we will be having our ground station. And if you see this, this is a very different hardware setup, and don't mistake this with telemetry. This is actually an RTK base station. So this provides 2 centimeter to like approx 2 centimeter to 3 centimeter level accuracy for our GPS drones. If you go with normal GPS, then you will be getting around 50 centimeter to 1 meter accuracy. If you go for some costly GPS like here GPS or something, you would be getting a pretty good accuracy. But if you attach this base and base stations RTK, then you would be getting 2 centimeter to 3 centimeter level accuracy with respect to RTK. So can our ground stations help for autonomous flights? First thing, it provides a lot of functionalities. Yeah, it does help us for autonomous flights, but not the programming related. We can have a waypoint navigations, and we can have some efficient precisions and navigations, and everything is predefined, but we'll not be able to control it instantly, or we'll not be able to change. Everything is static, everything is predefined. Before moving to the software part, so just have a look in the slide, and these are few terminologies which are required before. Like, it's not like only these are the terminologies, there are other a lot and lot terminologies. But while I was starting with the mission planner, so these were the few terminologies which I didn't actually understand in the initial stages. So you can just understand this. The thing is, there are terminologies like flight modes. Flight mode in the sense how your flight or how your drone need to behave, whether it should behave in a stabilized flight mode, altitude flight mode, altitude hold, or auto. Flight mode in stabilize means everything is in your control. So if you want to pitch, you want to roll, yeah, everything is in your control. Just that it stabilizes the drone. In altitude hold, the latitude and longitude or x and y is not constant, but the z-axis or the altitude is constant. So if you put in altitude hold, you will be able to move front, back, you can do whatever you want, but the altitude won't change. Yeah, even though you can adjust the altitude, but once you take the stick to center 50%, then you will not be able to change the altitude, it would be locked. And the auto mode, that's for mission planning. Whatever the missions you have done, it will be able to execute. If you put in auto mode, the mission execution starts. Then for controlling, there are a few terminologies: throttle, pitch, roll, yaw. Throttle in the sense the power which you are giving for motor. Basically, if you put more throttle, then because of stability algorithms, the drone would be balanced, but the altitude increases. If you use the pitch, then pitch in the sense it goes either the forward or backward. Roll, it tilts the sideways, so basically it would be moving sideways. Yaw in the sense it rotates, it changes its, well, let's assume you are pointing to north, then you want to point it to east, so at that time we would be using yaw. Then there are two different terms, ground speed and the airspeed. So you can just go through these all points. The only thing which are important over here is the arm and disarm. So even these all are very important and might be a little confusing, but yeah, let's stick with arm and disarm. So arm and disarm, if you are in a disarm mode, then even if you are putting n number of throttles, or even if you are changing any things, your drone won't react for that, because there is no power for your motors. I'll show a small video regarding the same. Basically this is in disarm mode, this is disarm, and now it is armed. So very simple. When the propellers were not moving, it was in a disarm state, and when propeller starts moving, when the motor gets the power, that is in armed state. So let's assume this to be our drone, and this to be our front direction. This is our front direction as it's mentioned here. So if we pitch it as it is mentioned, if you turn like this, the drone tilts forward, and because as it is tilting forward, the drone starts moving front, and if it tilts backward, then drone starts going back. Then we are having a roll over here. So if this tilts, it starts tilting sideways and it goes this direction. So basically it rolls, and if you roll in this direction, then naturally it goes this direction. Then we are having this yaw. So if you want to rotate your drone, if you want to change your headings, then yeah, naturally you can yaw, as it's mentioned over here. So in our mission planner, there's a lot of parameters and indicators that are being displayed. So you can just have a look over here, but yeah, once we jump into software part, we will be able to discuss more on that. Let's assume this is our transmitter. If I move this channel, if I move this stick like this as it's mentioned here, our drone rolls, and this is for pitch, in the sense front and back. Here if I take this stick up, then the more I take it up, the drone starts taking off, the more power we give for our motors. And if I yaw operates, so our drone just rotates. For drones, this is roll, yaw, pitch for control. Okay, let's start our mission planner now. So the installation process is very easy, like as you do for a normal software. So I guess you will be able to do that. Yeah, to start with the explanation of this particular software. So if you see, this is the first tab, data tab, and plan setup. So there are a lot of tabs, and first tab is the data tab. And in this lot of indicators and different values are there. So let's check one by one. So if you look at this first section, this is what we call as HUD, heads up display, or in short you can call it HUD or HUD. So if you just double click on this, it pops out, and if you are having some secondary screens, you can place it over there, or if you just close it, and again it's back over here. On this there are a lot of things. If you look at here, this is turn rate, this is heading, in the sense it's act like a compass. So basically as of now it's pointing almost like 360 or 0 degree. It just means that it's pointing to north. This is northeast, northwest. So as your drone turns, so this indicator would be changing, this heading would be changing. We call them as a, so this would be changing. And this we are having as a roll. So when our drone rolls, so this would be indicating the roll, like roll in the sense how much it's tilting sideways. And this, like minus 20 to 20, or like even further, this is called as pitch angle. So as drone starts moving further, so how much it's getting tilted, it will show that. And if you see here, this is airspeed or the ground speed, it's mentioned here also, airspeed and ground speed. Basically as it's showing meter per second, so basically this indicates the speed. Over here we are having meter, so and this is like 5, 10. So basically this indicates altitude. So let's, as of now our drone is in land position, so it's 0 meter. So as soon as it starts taking off, this altitude increases. And if you look at here, like you will be getting battery value, like what's my current voltage. If current sensor is there, then the current will also be shown, and what's the total percentage. Then here we are having GPS. As of now it's showing RTK fixed, because it's in a simulated environment, we are getting RTK. Otherwise we would be getting something like 3D fix or DGPS. RTK or 3D fix or DGPS, these are few different concepts which we will discuss in later stages, but as of now just remember that we are getting the GPS connection. Otherwise it will show in red color, GPS, no GPS. This is the flight mode in the sense how our drone behaves. So as of now it is in stabilized mode. So if I start taking off, it would be stabilized. it will always balance. Stabilization part, the drones control algorithms will take care. But what we need to take care, the altitude, the front, back, roll, yaw, these stuffs we need to control, and we would be having full liberty for that. And I guess apart from this there's nothing much. Here we would be getting RSSI. This 100% is RSSI, received signal strength indicator. Basically this indicates the signal strength or the telemetric strength from our ground station to our drone. So basically we can take our drone till this comes around 30 to 25%, and after that it would be little quite risky. So what's the telemetry and everything, so we have already discussed. But yeah, in future videos I will show you how to actually connect few different telemetries, the Wi-Fi telemetry or normal 3DR telemetry. And if you see here, it is showing the time also. So as of now it's almost 4:42 is showing that. And actually you can customize that, right? Just right click on this, and like so many stuffs are there, HUD items, so I have enabled everything. So you can do it, like you can modify with this, you can play with this, there is no issues. Now coming to the bottom section, this particular section, the first quick is something which displays the details, basically the altitude, whatever the things is here, the same thing would be displayed here. Home altitude, so what's my home altitude from sea, mean sea level. Airspeed, ground speed, so as of now it's zero point 0.0, so that's why like here it's being shown, it's showing with more accuracy. Channel 3 percentage, that's our throttle whenever I'm connecting my transmitter or my radio. And when I'm moving my channel 3, what's the percentage I'm moving, that it will show here. And here we'll get the roll in degrees, yaw in degrees. As of now it's pointing to 1, that's 1.3, it's pointing to almost north. Pitch is almost 0, means it's horizon, like it's horizontally, like in other words we can say it's parallel to the ground. If pitch is 0, it's parallel to ground. If pitch is like kind of 90 or something, we can just assume that it's perpendicular to the ground. The altitude error, basically the control algorithms or the algorithms which are there in the picture called the drones, it's capable of calculating the altitude error. So as of now it's showing 0, but what's the error, 0.04 might be the error. Armed, like as of now it's disarm. What's arm and disarm, we have already seen that area. So even if I do any changes, even if I ask it to take off, it will not take off because motors are not having any power. So if we arm this, if we change this to 1, then yeah, for sure it will start operating. Distance to home, as of now this is my home. Let's assume this is the point from where we'll take off. How to set home, I'll explain shortly. But yeah, let's assume this is my home, and how far it is from home, so it's almost 3 centimeters away from home. So if it from here, if it goes here, and what's the distance from here, like it will calculate the displacement, and here it will calculate the distance. Distance to the waypoint, the next waypoint, so this we will discuss very shortly. Vertical speed, how fast it's climbing. What's the battery percentage remaining, so as of now it's still 100% because we just started the simulators, and it's connected to simulator. Actually it's actually a simulator now, I have not connected the real drone. And what's the battery, almost 12.6. In essence, like I have connected 3 years lipo battery, not actually, let's assume in simulator I have connected 3 years lipo battery. In actions tab, so in this only two things we need to consider. One is return to launch and missions tab. So let's start with return to launch. So in this, if you select return to launch and click do action, what will happen? Let's assume this drone has taken off and it has gone somewhere here, and some issues have happened, and I want to get my drone back on a auto, like I don't want to control it. Maybe my transmitter has broken or any some thousands of different issues, but yeah, I want my drone to come back automatically and land over here. That's basically return to launch. So if I select return to launch and if I just click do action, wherever it might be, it will go to certain altitude, the RTL altitude, that can be 15, that can be 30, we need to set it. We can set it in configurations tab, I'll show that very shortly, but the default might be 15. In my case it was 15, so it will go to the 15-meter altitude. Once it goes 15-meter altitude, it starts coming in a displacement manner. No, it will not consider the distance, like if I had gone like this, It will not come like this. That's smart RTL. But by default, it will draw a distance and it will start coming in a displacement manner, and it will come and land. Once it lands, immediately it gets disarmed. That's what RTL does. Then we are having mission start. In plan tab, we can plan. For example, from here, take off, go here, and then here, and from here, take RTL. So this kind of stuffs, the predefined missions or predefined programs, this we can do. And to start that, we need to select mission start and we need to click do action. In second thing, we can set waypoint. Let's assume as we were taking off, first waypoint, second waypoint, third waypoint, and fourth waypoint. There were different waypoints. We can set which waypoint to directly go. Then we are having a lot of flight modes, as it was in stabilized mode, the first one, in the sense like drone would be operating normally, it will be in stable mode, we can control however we want. Then acros, then we are having altitude hold. In this, a lot of different flight modes are there, but let's select only few. In altitude hold, as the name suggests, only altitude would be locked. You can move x, you can move y, I mean in the north direction or in east direction, or in negative north direction, that is south, or in negative east direction, that's west. So basically I'm considering northeast down reference. So in altitude hold, the altitude would be locked, you can move it. So basically what will happen, we will take off the drone, we will set some altitude. Once we set that altitude, we bring our channel 3 or the throttle stick to 50%. Once we get 50%, once the input is 50%, that's being shown here, channel 3% is 50, then immediately our altitude hold will be activated. Basically we need to select this altitude hold and we need to set the
Robo Rose X mode alt hold.
see, like it's an altitude hold now. So we can actually change the altitude now because channel 3 is not exactly 50%, so it would be descending. If it goes above 50%, it will start ascending slowly, it will be ascending or slowly it will be descending. But once you make it 50%, then the altitude would be locked. You can start playing with in a front, back, like in the sense pitch, roll. Yeah, you can start playing with that. Then we are having auto. So this auto is important. Basically the mission start can be done, but if we don't have access to our mission planner, we have pre-programmed everything, we have saved in the pixoc or whatever the flight controllers we are having, and now we want to start the mission, and we don't have the laptop or we don't have the computer, we don't have any Android devices, and we want to start the mission. So how to click this button? So basically we are having a kind of flight mode for that auto. We can set it to any of our auxiliary channels in our transmitters radio. So once we activate that flight mode using our radio, then so basically mission start and auto both are same, just that mission start is we can do it using the mission planner, and auto, yeah, naturally we can do this here also or through the radio also we can do it. And naturally like a lot of different algorithms are guided for programming loiter for, it's almost like stabilized, but GPS would be enabled and it would be locked. Even a strong wind comes, it will not move. In stabilize, if a strong wind comes, then slowly it will be drifting, you need to keep on adjusting. In stabilized mode, you need to keep on adjusting if it's going because of wind directions or because of bad tuning. If it is not so stable or if it is drifting, then you need to keep on adjusting. In loiter, it will take care, so you don't need to worry about that. Then RTL, you can set it here also, circle. Basically it starts making a circle with a fixed radius. You can land it, you can drift it. Sports and acros are very different. They are used for high performance or high speed things. Flip, you can flip it. uh, Auto tunes is basically to calculate the PID, let's ignore that. Position hold, so as altitude hold was just locking the altitude, in position hold everything would be locked. So if you just drag it manually using some rope or like with hands, if you move that, and as soon as you leave it, immediately it will go back to the position where it was initially put into the position hold. Basically you can't move that. Brake, if you are going at a very high speed or when you are going, if you put the brake mode, then immediately the drone will be stopping. in the mid-air. Naturally, it will not get disarmed, it will not fall, it will just stop there. It's like a air brakes. And different flight modes are there, so you can just check them in official documentation. The smart RTL and RTL are both almost same, just that in RTL it will consider the displacement. So from here, let's assume it's here, it will come like this. But in smart RTL, if you had gone like this, then in smart RTL it will come like this. So basically, it will consider the distance which you have already traveled. It will just consider that as smart RTL. Then so many different things are, so you can just consider. And same things are over here. Some important auto loiter RTL. The same things are. You can also control some joysticks. You can attach some joysticks. As of now, you can see I have attached FSI6 recently. So you can just select that. You can calibrate, or you can set which all the sticks need to operate at what all the things, XYZ, RXRY, like so many stuff should be there. Once you set this, once you are comfortable with that, then just enable it. You are also having like a functionality to auto detect. Naturally, this process we will show it in a different video, but yeah, like I'm just explaining the what all things the mission planner is capable of. So in just the data tab, so many stuffs are there. So if you just enable it, then naturally you'll be able to control your joystick with the mission planner. Whatever the movements you do in your joysticks or your radio, that would getting reflected for your drone. Then let's this restart mission. Once you land and you want to restart something, just click on this raw sensor view. If you just click on this, like you would be getting the raw data. You can see like accelerometers, gyro data, your roll pitch. Your as of now it's like constant, so you'll not be able to see anything. But once it starts flying, once it's up in the air, then a lot of things, these graphs would be moving a lot, and you can get the CSV data also, and with that you can get the radio data also. That's the advantage. Basically, these are for pro developers. You no need to worry, because these are pretty advanced concepts, so no need to worry about this. Just I'm as of now I'm just explaining what are things this mission planner can do. Then we are having this button arm and disarm. We are having this drone here. As of now it's disarmed, in the sense the motors are not getting power. Our motors are not getting any power. Even if I give 100% throttle, our motors won't spin. But as soon as if I arm this,
Robo Rose X Omni Tech Solutions drone armed.
so once it's armed, the drone is getting power.
Robo Rose X Omni Tech Solutions drone disarmed.
So one thing what you have observed, as soon as I arm it, I'm having a very short time to increase my throttle or to start my mission. Otherwise, immediately it will get disarmed. That's very important and very important safety feature. So you can't just keep your drone in an armed position for a very long time. Once you arm it, then you need to start your mission, or you need to start with the throttle stick. You need to increase it for 5% or the 10%, and then keep it. Naturally, because of drone's weight, it will not take off, but still it will be in armed position only. Or if you keep your channel 3 or the throttle stick at 0 position, then you would be having a very less time. Let's assume maybe 7 seconds or 10 seconds. That seconds also we can change in the configuration tab, but by default I guess it's 7 to 10 seconds. Within that you need to start, otherwise again it will be immediately disarmed, just for a safety purpose. Then we are having pre-flights. So you can see it's verify GPS. So we are, it's in a green, and the GPS satellite comes, and satellites we have connected. Telemetry signal is 100%, but if you see battery level is 12.59 and it's showing in a red color. As it's in a simulator, we can ignore this, but let's assume that we are flying a real drone. We need to check why this is in a red color, or why this is showing. Even though 12.56 or 59, it's a pretty good voltage, and we are just flying with a 3S like a battery. It's almost 100% full charge. So we need to consider. Let's assume verify GPS. Minimum is three. We need minimum three satellites. And how many satellites we are getting? We are getting. So that's the basic stuffs we need to check with. And same thing would be displayed here also. SATS is 10 satellite counts, and HDOP. This HDOP is important. So 0 is ideal condition, very accurate positioning. 1 or 1.2 is too good. Uh, it's almost accurate. Till 2 3 is also pretty fine for environment something like this where there's no one or no obstacles are there. That's pretty good. But as this starts increasing, as HDOP starts increasing, we need to start worrying about the GPS accuracy. It might glitch, or it might have like the accuracy is very poor. So then that might create a lot of issues that we need to consider over here. Okay, then we are having some. I guess I don't need to explain this. These are pretty well explained. This is speed and this is altimeter. This is, as of now, it's pointing to north. That's basically this. And as our drone starts flying, it will be showing that where it's heading, or in in which direction it's heading. So many different stuffs are there. You can control the servos which are attached to the pixels. That's again we can consider in some later stages. Okay. Uh, this particular section, I guess that's enough. One thing which I actually want to show, let's assume I want to change this arm, or like let's assume I don't want this vertical speed. So what other things I can set? Are only these the parameters which I can see, or can I change it? So if I just double click, you can see these many parameters are there for me, which I can set it for in that position. Naturally, these are all same for every different positions, but yeah, as of now, I had set for vertical speed. You can set it anything. Now it's 4 cross 4 matrix. How to change that to, like, let's assume 2 cross 2, or let's assume 5 cross 5. Just right click, set view count. As of now, I'll give columns to be 5 and rows to be 5. And now we are having 5 cross 5 matrix. You can see these are unassigned. Naturally, if I just double click and let's check, I'll assign them as a battery count 1, cell battery cell 1. So now we are getting that. Or if I just change it to maybe like pose, now I'm getting the pose. Like we can just play with this. I have set to UID, both are same now. You can set two different stuffs. I don't want that. So what I'll do, 4 cross 4 was my perfect one. I only need this much. Okay, now let's come to this particular section. This is the zoom and zoom out. Naturally, no need to explain that. Here we are getting the current latitude and longitude, current heading. So this red line is where it is currently pointing, direct to current waypoint. So let's assume there's one waypoint over here, and next it's going here. When it's moving here, so naturally the orange or this yellow line would be pointing to the current waypoint. The target heading, so basically if you see here, that green color line is not exactly being displayed, so we can ignore that. Then we are having the black, that's over here, that's the GPS track, or where the or GPS is being pointing. Okay, after that there's one thing called tuning over here. If you just enable it, you would be getting your role, the actual, and the roll target, or the pitch, or the pitch target. So these are important when, like, only for the advanced users. If you're a beginner, you can just ignore that. Okay, considering this auto pan, so let's just observe this. I'll move it here and I'll wait. Nothing happens. I'll enable auto pan. I'll move this and I just wait. And again, the drone immediately came to the center of the screen. Again, I'll move in some different directions and I'll just wait. Again, the drone would be aligned like at the center. So basically, when your drone is moving, you don't need to keep on moving like this. Basically, if you just click this auto pan, then the screen would be following your drone, and it will always try to maintain your drone at the as center as possible. That's the thing. So yeah, this is all about the first tab, that's the data. But in this, or like in everything, there are few common things. That's this one. If you just check this, because I have already connected, so I'll not be able to change them as of now, but let's just check with this. TCP is your transmission control protocol, or like basically I have connected using some Wi-Fi technologies. In simulator it would be a Wi-Fi. but even you can, when you put Wi-Fi telemetries, then you will be getting the respective protocol over here. If you connect using some normal telemetries, then you might get com ports. So basically we would be getting com 4, com 5, com 6, whatever the respective comms you would be getting. This is baud rate. As of now you are getting this baud rate for the default Wi-Fi, and you can change this, but as of now these are the standards which simulator permits, so this is constant, no need to worry about that. But when you connect the normal telemetries, the serial based or com port based, then the default would be maybe 57600 or something like that. And this is the drone TCP at port number 5760. This is my drone that's being connected. If I connect to multiple drones with the same mission planner, all drones would be displayed over here, and we can select which drone we want. And how to connect multiple drones, because as soon as I connect, this is in a disconnect position, so I can't just disconnect. If I disconnect this, then this would be lost. If I connect the other one, I can't connect this back. So to connect that, over here you just need to right click, connections option, you get this, you select the protocol. Let's assume I will select the UDP. You select the baud rate, the thing which I was saying for comport 57600. Basically for the normal things I'll be selecting this. Then you just need to connect. As soon as you click connect, it will start scanning and it will ask for port, which port basically. There are like you need to know your port, and how to get your port and everything. I will tell in some later videos where I'll be explaining you how to connect node MC or ESP8266 to your pixel. But as of now just ignore this. But yeah, if you know your port, just connect here and click OK. Okay, fine. I guess everything is done in this particular window. Now let's jump to the plan section. So yeah, in plan section, this is how it looks. The data section looks like this. The plan looks almost, again you are having the same map. Here the auto pan won't be there because you need to sometimes you need to plan very long distance. So if it again and again if it starts coming here, so it would be a very problem for us. So in this section the auto pan won't be there. That's pretty obvious, and you can plan over here. So let's start with a few things over here. Distance, you can see it's not changing, but basically when you click here, let's assume I'll make the first waypoint here, then you know what exactly is happening. So it's almost zero point 0.1 kilometers front. Then if I click here, the total is 0.9. The distance from here then here is 0.19, and if I click here, 0.4. So by default it's already traveled almost half a kilometer. So that's how you can plan, and that's what it indicates actually. The second one is you can see like as I'm moving my mouse, it is showing like how far it would be and everything. And that AZ is your direction. See, as of now I'm pointing to north, my mouse is almost to the north, so that's the direction. And if I start going like this, it starts increasing. To east it is 90-degree. Yeah, this is my east, almost east. This is 90-degree, and 180-degree is my south. This is west, and again north. This AZ indicates the direction. Then home, like how far my mouse is from home. So if I'm here, then it is 100 meters from my home. And you can see the home location is here, that H, it's hidden. Yeah, you can see that H is we this is how we need to set our home position. Or else you can just click here if you are connected to the real drone with actual GPS, then your drones, and if you just click on this, then that would be your current home position. Otherwise you can put latitude and longitude default values from Google Maps. Otherwise you just click on lat, and it will ask you to click on the map. Let's assume I'll click here, and that's your home position. So one thing, you can drag and set it. Otherwise you click on lat and you click wherever you want, that would be set. Otherwise you can manually change there. You can change these values. Basically what will happen, like it will ask just close this and change over here. That's the thing. I'll set it here itself because that's the it's looking pretty nice. Okay, now let's come over here. There are two options over here. Basically these are not so required. If you just click on this draw polygon, clear polygon, some blah 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 stuff, here these are related to zoom vehicle, zoom to the mission, or zoom to the home position. That's its all. So even if you right click somewhere, the same stuff you would be getting. Okay, now before we start actually doing the mission planning, let's consider few stuffs over here. The first one is WP radius. I'll just show what exactly it happens. I'll click here, and this is where I need to reach. From here, I need to go like this, and this is where I need to reach. Then from here, I need to come over here. With this point, there's a circle. So let's assume I'll change that circle's radius to 20. You see that? It's changing. So what exactly is happening? When your drone is going to that point, if it enters that circle, if it hits that circle, if it enters into that zone, then it will assume that it has reached that particular position. These are very useful when you are going at a very high speed. So because of momentum and all stuffs, sometimes this might be required. Or if you want to achieve a very high level of accuracy, then even at that time these are important. So this is a 20-meter circle radius, 20-meter radius circle. So as soon as this enters, it will assume that it has reached over there, and it will start going like this, like it will, or it will just take a turn over here itself. And as soon as it comes over here, it will assume that it has reached here, and it will start coming back. No, no, it will actually not come back because we have not yet programmed that, but it will just assume that it has reached over here. And like let's assume that I have given it just one. See how small it became. So it just means that we need to be very accurate. Our GPS should be very accurate, and when the drone reaches there, it will reach very accurately. So these are integer values. So what if I give floating values? I'll give 0. Maybe 5. Will that take? Will this mission planner take the floating values for WP radius? See, it has become much smaller. So basically, this is a 50 centimeter radius. So our drone will be going in a much more accurate manner while reaching there. So these are the different stuffs. By default, we can keep it 2. This is pretty good because, anyways, because of speed issues and lot of other stuffs, majority of times it will reach pretty accurate. We no need to worry about that. Then the default altitude. Let's assume I'm clicking here, and everywhere I'm clicking. I'm selecting the positions, latitude and longitude. But what about the altitude? You can see here by default it's 5. You can double click and you can change it. There's no issues. Again, I'll make it 500, much more altitude. We can do that, no worries. But yeah, by default it would be 5 meters. So if you set maybe like let's assume I'll set it for 500 as default altitude. Okay. Okay, so default was 500, so it's getting 500 everywhere. And naturally I can double click and I can change it. No issues. You can change latitude and longitude. If you don't want to click and you are having the latitude and longitude, just double click and you can set it over here. You can also add the delay, like once it reaches there, before it goes to the next waypoint, the delay that need to be given, you can add that also. So these are the stuffs how you plan the mission, but not exactly, this is not how you need to plan the mission. But yeah, there are a few certain steps for that, I will tell you shortly. But yeah, before that, let's check this mission tab. With this there are few other stuffs: fence and rally. The fence in the sense, like as soon as you start clicking, you can set a zero fence. Your drone won't cross that. These are the positions, like it will not enter this. Or you can draw polygon as initially it was giving the warning. So this is also a possibility. Or you can set the rally points. So what are the rally points? To explain exactly the rally points, let's assume my drone was here and these rally points are not there. My rally points are not there and my drone has went somewhere here and I put it RTL. Naturally, it will come to the home position or where it was taken off. Like as RTL means return to launch. Let's assume it was launched from here. It will come and land over here if it was launched from here. Basically, majority of times it will take off from home position. So sometimes it will come to the home position. But if I put some rally points here and if I put RTL, the nearest rally point it will come and land over there. So these are the trusted sources or the trusted places where my drone can land. Let's assume it's here and it's coming to the position from where it was launched. Let's assume from here it was launched. So it's coming and we are getting the first rally point and this is the nearest. It will land here. And if I put some rally point here and it's coming from here, it will just land over here. The rally points is the trusted place where we are giving authority for our drone to land. And if we are not having any rally points, then whatever the point where it will actually store or from the place where it actually taken off, there it will go and land. That's the rally point. Now let's start with the mission, the actual mission planning. I'll set this again by default to 5 because I don't want to go till 500 meters, like half a kilometer. Okay, our drone is ready to take off. Now I want it to take off, and let's assume I'll place it here. So I want my drone to take off. So this is the waypoint. I want it to convert to a takeoff to the altitude. So it's ready. What happens if I place this here? I'll just drag this. Okay, for just a second. This takeoff. Okay, just a second. Yeah, I'll place it here and take off. What happens if I give takeoff over here? Slowly it will ascend while reaching here. It is a takeoff phase and it will fly like a fixed wing. Slowly it will increase its height to 5 meter. By time it reaches here, it would be 5 meters. So slowly it will take off. So I don't want that. I want it to take off like a normal drone. I'll place it here. Okay. So this is takeoff. Now the drone is at 5 meters. Now I want my drone to go here. You can zoom it so that you can be pretty accurate. And as soon as it reaches, I want it to go here. Then probably like let's assume here. Once it comes here, I want it to land here itself. Don't come back. I want it to land. That's it. Our mission is ready. So here 5 meter taken off altitude, then 5 meter it maintains, it goes here again. By maintaining 5 meters it goes here, comes here and it lands here. Even if you check, take off 555 and while land it's 0. Let's just change the altitude. At waypoint 3 I want my drone to reach at least 15 meters. So basically it will go till here at a 5 and while reaching here it will go 15. Okay, very simple. And it will come at 15 and here it will start landing. Here it will start landing. Okay, I have the mission ready. Now I want to upload it. Just click on write. The mission is being uploaded. What I will do, I will clear the mission. The mission is gone. It is just a confirmation. I will just press read. And if my mission comes back, then it's successfully saved into my Pixel or whatever the flight controllers we are having. After clearing the mission, if I just press the read, if it comes back, then it's been successfully stored into my flight control. Then I will go here. I need to set this to pretty like auto mode. That's the thing which we need to select.
Robo Rose X mode auto.
Pretty.
Heading to waypoint 1.
We need to
Arm. Auto mode not armable.
see in auto mode we are not getting permission to arm. So let me keep it stabilize itself.
Robo Rose X mode stabilize.
We are in stabilize mode. We arm it
Robo Rose X Omni Tech Solutions drone armed.
to action.
Robo Rose X mode auto.
And you see the altitude increasing here.
Heading to waypoint 2.
You can view the raw sensor data.
Heading to waypoint 3.
See, now it's climbing to 15 meters.
Heading to waypoint 4.
While going to waypoint 4, it's maintaining 15 meters. Okay, it's almost same. You can check here the altitude. Yeah, altitude is almost 15. You can get the tuning also. You can see how the things are happening. Now it's landing. See, initially I was in stabilize mode, but as soon as I clicked on do mission, the start mission, then it automatically converted to auto mode. Now it's landing. After it lands, it should automatically disarm. Okay, as it's not at move.
Robo Rose X Omni Tech Solutions drone disarmed.
Okay, our drone is disarmed. This is the thing how we need to plan the mission. But yeah, um, pretty good. No worries. It was doing pretty good. What exactly we wanted to do. We can add hundreds of waypoints, but yeah, there would be certain limitations or restrictions for the number of waypoints that you need to check on your own. Let's close this mission and let's try something very different in the sense, let's assume, let's go somewhere. Okay, I'll just choose this area I want to do a kind of survey. So how to do that? I'll right click, there's a polygon, draw a polygon. I click the my triangle or the rectangle or pentagon, anything I can do, or I can just delete this. So this is the area where I want to do my survey, or even I can put an extra waypoint and I can adjust it however I want. Otherwise I can just delete that. Delete in the sense, just right click and press delete WP. That's delete waypoint. Now we are having our polygon over here. Once the polygon is here, just right click, auto wayp, that's auto waypoint. It will create auto waypoint, and so many stuffs are there. Survey is there, survey version 2 is there, like maybe like that v2. I assume that it's a version 2. I'm not pretty sure. Simple grid is there, so let's just select any of survey or survey grid 2. Anything is fine. I have selected this. Okay, once I have this, by default it will showing here the total distance the drone will travel, that's being shown here. Distance between images, that's being shown. And the ground resolutions, if I put any cameras over there, and how many photos it will take, and how many strips, that's basically showing four. That's a one, two, and three, four. Four strips. Distance between the lines, so from this line to this line, it is almost 6 meters, and it will fly for almost 1 minute, and almost every 1 second it will take photos. And similarly, you can understand whatever the cameras you have fit, or if you want to change, you can change your camera according to this. I don't want to go into the cameras part. And my altitude is 1 meter. It has all automatically taken altitude to be 11. Altitude is 11. So what if I decrease this to see like 1 meter altitude, and I want to do a survey of this? So it basically takes 9 minutes. It's pretty common sense. And ground resolution is almost 0.03 centimeters, which I guess it's not required. Let's put this to 5 meters. I'll just click somewhere else, and as soon as it detects, it takes 2 minutes. And that's what, like how we can create the auto waypoints. Let's keep it for 15 minutes so that we don't waste much time while recording these videos. So 30 seconds. What I'll do, I'll just accept it, and it's created. You can see everything is auto created. What you need to do, write it, come over here, get the action tab, be into the stabilize mode,
Robo Rose X mode stabilize.
arm it,
Robo Rose X Omni Tech Solutions drone armed. Robo Rose X mode auto.
and it's starting. It's taking off.
Heading to waypoint 2.
I'll off the auto pan.
Heading to waypoint 4. Heading to waypoint 6. Heading to waypoint 8.
You can see here 15 meters. It's maintaining that. And waypoint 8 is this many meters.
Heading to waypoint 11.
Waypoint 11, these many meters far. You can see that over here. What it will do after coming over here. Let's wait. You can see the altitude started decreasing. So basically it's landing actually. While these stuffs are happening, you can actually see here. It's in armed position. As soon as it gets 0, then motors are off.
Robo Rose X Omni Tech Solutions drone disarmed.
So this is how you can create the survey, or you can do the agri spraying machines, or a lot of other stuffs. You can just remove this waypoint, come here, clear polygon. Okay, I just want to show you one more stuff. Very one more important stuff which we need to consider every time. Let's assume I'm going here, coming here, over here, and I'm making a turn. Basically, we will be following this path. And if you see here, frames, there are different frames: relative, absolute, and terrain. Relative in the sense, from the place or from the position, this would be 0. The altitude would be 0, and from here it will take off to 5 meters. In absolute, what will happen from the mean sea level, that's 5 meters. Let's assume I'm into the northeast areas or in north part of India, where the altitude is by default very much high. And if I just give 5 meters and take off, then naturally my drone will never take off because sea is much down, and I'm asking from the sea level to 5 meters, and that will not work. So basically absolute is like only when I know my current altitude from the mean sea level. Otherwise we can keep this relative. And what's this terrain? Let's assume there's a mountain over here, and it detects and it knows that the height of mountain, and accordingly it will adjust. That's the okay. I'll just show you one stuff over here. I'll keep this absolute. First it will take off for relative 5, and I have given the absolute. Then I'll click here. Then there is something called tools, map tools. Then here, elevation graph. And if you check over here, if by chance these two are meeting, the blue and red lines are meeting or intersecting, then it just means that our drone is crashed to ground. Basically here, if there's an intersection, it just means that from the ground position we are taking off. Pretty good. And as soon as we reach the second where like our second waypoint starts, reaching to the mean sea level 5 meters. So this is 0, this is C, and from here 5 meters, and here is our ground. We are crashing, and these other stuffs won't happen. I'll just close this, and this absolute I'll again put it into relative. Come over here, map tools, and if I get elevations, you see this is my ground, and this is how my whatever the mission is happening. Initial takeoff phase, and then it's just moving because I have not given land. Let's give the land position over here. Yeah, land, and then just check again. You see it started taking off, comes, and it lands. It's trying to land over here because this was the initial reference. This was the initial reference, and it will try to land over here. But as it is not possible because we are having this different kind of terrain, let's assume this is not happening. So what we will do, we'll change this relative to terrain, and let's check now. You can see takeoff relative it will forget, but the current ground position, there it will go and land. So that's the thing which you need to consider: the absolute, relative, and terrain. Majority of the cases, I hate using absolute because I don't know my current sea level or the altitude from the sea level. So I'll ignore the absolute. Relative and terrain. If I'm at a very even place, relative is pretty fine for me. Otherwise, if Google is providing sufficient data for me, then terrain is the best thing for me. Okay, this was all about the plan section. Now let's go to the setup section. In setup, one thing, you can install the firmware. Like when you get your Pixoc, it won't be having any code in that, or it won't be having any firmware in that. You want it for, or a like quadcopter, you want for hexacopter, you want for octocopters, whether you want for a auto rover or a fixed wing, you don't know that. So basically, when it is in a disconnected state, I'll disconnect it, click on install firmware, and these are the things. It should be in the disconnected state, then only it will show these all stuffs. You just decide whether you want a rover, a fixed wing, a quad, hexa, like this kind of, where it rotates in a opposite directions, submarines, antenna trackers, helicopters, tricopters, so many different stuffs are there. Octocopters is also there. So it depends how you, which one you want to select. I'll select this one as of now. And do you want to like upload this one? Yes. Like naturally, I have not yet connected to anything, so it will fail. Basically, I'm starting the simulation. Or you can install the legacy firmwares. You can load your own firmware, pick previous firmwares or load custom firmwares. What are these custom firmwares? So if anyone has developed some other firmware for a Pixel, maybe the algorithm part, or they added few extra stuffs. For example, there is a Skybrush firmware is there. It's for Pixel. So you can upload that using the load custom firmware, or you can download, or like so many other stuffs you can do. Again, it's same. Pick previous firmware. If you just select this, then you can select which version. So a lot of versions are there, so you can select which one you want. Once these are done, then I guess everything is coming to the optional hardware. The RTK GPS, so you can start with RTK related stuffs, or you can connect SIK radios and so many other stuffs. Again, the joysticks, which we initially we got it from this action tab, the same thing again you are getting it here. And naturally you can do the Bluetooth setup, or the flow sensors in advance. I usually ignore that, basically for getting the lidar related distance and everything. This is the thing. But let's yeah, ignore the advanced section and optional hardware, and let's connect that. So what's the exact thing in setup you get only after connecting it to your drone? So for connecting, again I will go here and I will start the stable version, and we will wait for downloading. Once you have downloaded it for once, you can click on this skip download button. You can set the simulation speed also here.
Robo Rose X mode stabilize. Robo Rose X mode stabilize.
These are the few parameters which it
AHRS,
will download or
EKF3 active.
drone. Okay, let's clear this. We were in the setup, and once I connect, according to my vehicle, I'll get this frame type. I can set the quad, hexa, octa, or like whatever the stuffs, based on the frame. How my frame is there, we can set that. We can calibrate our accelerometers, calibrate our compass, calibrate our radio PWM or PPM signals. We can do ESC calibrations. We can set our flight modes, like for our radio, the toggle switches. We can set failsafe. So what this failsafe? If our battery goes below this voltage, then what it need to do? That we can set it here. Or like if our radio gets fail, or like my transmitter, because of low battery or because of long distance, there's a communication break. So at that time, what it should do? So these are few stuffs where we can set the failsafe. Then we are having advanced concepts like ADSB. uh, this is pretty advanced concept. There's a sensor, or there's a module or a device. If you attach that, then you will be able to detect nearby commercial vehicles, and if any vehicle is coming towards your drone, then it will try to avoid that. Let's assume there's a small commercial plane, or there's a Cessna kind of stuffs. The trainee aircrafts are coming towards your direction. You are flying at around 300, 400 meters altitude, and in your direction, aircraft is coming, and naturally, it might lead to a lot of dangerous stuffs. So, if you purchase this ADSB module and if you put that into your Pixel, then it will be able to detect that, and it will try to avoid it, or at least it will show in your here. Here it will try to show that. Okay, you can ignore the ADSP also, like if you are a beginner and if you are not going above 50 meters or 100 meters. Okay, I guess that's enough for the setup section because it depends on the. Now comes to the configurations. In configurations, let's start with the planner. Here you can set your camera, the video format, the speech, like whenever I was arming, it was giving some voice note. So whether you want that or you don't want that, you can do that. Again, the joystick setups, the unit which the default SI unit which you want. Basically, I have kept it for meters and meter per second. The telemetry rate and few others. You can play with this, no worries. Then comes the full parameter list. This is very important, but you don't need to remember all, or you don't actually need to remember any of them. It's all about the documentation. It's all about that particular stuff which you want to control. Let's assume I'll just type RTL in search. I have given RTL. As I was mentioning, RTL altitude is 15 1500 centimeters, 15 meters. So initially I was explaining that whenever I click on RTL, it goes 15 meters. So this is the thing. If I change it to 30, then naturally it will go for 30,000 centimeters. If I just do this, then naturally it climbs to that many meters in centimeters. And you are having the options 200 to so and so. You can set anywhere between that. 200 meters minimum 2 meter altitude, and this is the maximum altitude you can go. Probably we can cross this, but not recommended. And yeah, regarding altitude itself, we are having so many different stuffs. It depends. So okay, I'll just get back to default and I'll keep it for 15 15 meters. Okay, then let's check WP, that's waypoint. In waypoint you can see like there's again waypoints navigation speed is the, then radius, that's 200 centimeters. So I'll change it here and let's check whether it will update over there. I need to write this. Are you sure? Yeah, okay. Let's check over here. See, here it has updated. 7 meters it had come. So basically a lot of stuffs are there which you can try over here. It actually depends on what exactly you want to change, which configurations you want to change. It actually depends, and a lot of documentations is being written, so you just need to follow that. In simulation tab, nothing much to discuss. You can, like if you have already downloaded, you can skip downloads. You can set the simulator speed, like as of now it is by default, like how it will be behaving in the real environment. It's almost similar. You can make it 2x, 3x, 4x. You can do that, but not recommended because let's assume that you want to arm. You like you have get the simulation speed as 10. You arm it before you go here. It would be disarmed because simulation is at a very high speed. So this would create a problem. You are having the models, different models, X plus quad, so many different stuffs. You can do the swarms also, or better what I suggest, directly click which you want, just click it, then directly it will start the stuff. This is all about the mission planner. So let's just for fun, I'll disconnect this and I'll try to start the rover. So let's wait till it gets downloaded. I guess it's downloaded.
Robo Rose X mode POS hold. Robo Rose X mode manual. EKF3 IMU1 initialized.
So this was the thing which I've already tried, I guess, because it was already pre-written in my rover. Anyways, I hope this
Unhealthy
will give you a lot of
AHRS.
difference. and I'll just write this. So it's again a fresh, it's in a manual mode, so modes changes over here.
Unhealthy AHRS.
And this is my rover, and I'll just arm this
Robo Rose X
and
Omni Tech Solutions drone armed.
maybe fly here.
EKF failsafe cleared.
Don't require the altitude.
Robo Rose X mode guided.
My rover starts moving over there. As simple as that. And it's moving at a 5 meter per second. Or else even for this.
Robo Rose X mode RTL.
For this also this data works, but naturally you won't be getting the altitude because rover won't fly. And you can see altitude is 130 meters, so you can just ignore that. I guess it's showing the mean sea level, like above what's the altitude above mean sea level of this rover, so we can ignore that. Here we would be getting some messages, telemetric messages, again not so important for us like as beginners. Okay, let's plan something with this rover. I want it to go here, then here, here, maybe probably here, and come and stop. So what I'll do, I'll write it, come here, do action, start.
Robo Rose X mode auto. Heading to waypoint 1.
Like because here once armed, it's in the arm state, and it just follows.
Heading to waypoint 2. Heading to waypoint 3.
Thing is changing the magnetometer, like the compass.
Heading to waypoint 4.
It will start moving to waypoint 4, and it's these many meters far. Now it will become 5, and let's see how many.
Heading to waypoint 5.
See, it's trying to match as much as possible naturally while turning because of that waypoint radius and everything. So this much is okay, but see, almost it's matching.
Heading to waypoint 6.
Once it comes over there, I had not given anything, no RTL, nothing. So it just stops there. And if I just press RTL,
Robo Rose X mode RTL.
from there it just returns. Okay, this is all about our mission planner. We can do a lot of stuff, and still there's a few things like here in advanced sections. You can do the lidar related stuff. You can do control F. You can do the swarms over here. You can actually get the mailing messages and just try to read that. You are having the follow me using the GPS related stuff. So many advanced stuffs are there. Like if you open the swarm, it's still in the beta, but yeah, you can do the swarm related activities or the projects here itself. So still a mission planner is much more than what I have shown till now, but as a beginner or for people who are from computer science background who just want to simulate this or who want to just simulate their code and try whether it might be working correctly or not, though there are many clone modules available in the market and your code might not work really good with them, those modules, but yeah, in simulated and in ideal environment, if your code is working pretty fine, then you can take a risk before going to the actual trials. If you just check in a simulations, then it would be highly recommended.